All right, so let me cover PIM source specific multicast or SSM. This is the agenda for this session. Overview, we'll go through the overview, use cases, details and caveats, the configuration, best practices, how to troubleshoot it, finally a demo of it. PIM-SSM, 10.9 adds support for this, but it's for non-VXLAN, non-VXLAN, okay? This will allow multicast receivers to request for multicast stream from a specific source. This is an example. I have a receiver here. He wants to join a specific source. This is the unicast address of the source, 2.100, and this is the group. This is the SSM group that he wants to join. So S-G is source and group. So you can see only the S-G is used, not a *G for SSM compared to normal PIM sparse mode, where you do not actually want a specific source. So this is really suitable if there's one source stream to many receivers. And something to be aware, FHR, first hop router, that's the router attached to the source. LHR, that's the router attached to the receiver. So this term will be used throughout the session, LHR and FHR. SSM no longer requires rendezvous points or RPs. That's used by normal PIM sparse mode. So for SSM, in 10.9, both IPv4 and IPv6 are supported for non-VXLAN. For this to work, the receivers need to enable IGMP-v3 for IPv4, MLD-v2 for IPv6 between the receiver and the LHR. This to inform them the specific group they want to join. Okay, so most software stacks on clients support these. These are the supported platforms for SSM. Right? You can see many switches do support this in 10.9. Use cases. So you can see here, I have this use case. Some receivers want to join from this source to 2.100 for this group. There's IPv4 address on top. If it's IPv6, they can do this, right? Source, IPv6 address, unicast address, and the group, IPv6 group here. So while other receivers want to join the same group, but use a different server, a different source. So this 2.101, the purple server. So you can see there's no duplicates. Even though they want to join the same group, they can request from specific servers, specific source servers. So that's the beauty of PIM-SSM. There's no conflict, even though they're duplicate IP groups they're trying to join for IPv4 and IPv6. You can see here again, IGMP-v3 or MLD-v2 is used from the receivers to the LHRs. And SSM is actually between the routers, LHR and the FHR and the transit routers in the middle. So these receivers typically join the stream via a web page. They click on it, so that web page will tell them where to go to for the source. So details, multicast routing is heavily dependent on unicast routing. It will not work if your unicast routing does not function. Okay. So you need to make sure that your receiver has layer 3 unicast connectivity to the source. Make sure your pings work from the receivers to the source. And you see that the IGMP v3 or MLD v2 joins are sent. You need to make sure this will work as well from the receiver to the source, connected LHR. After that, this is sent. These joins are sent from the receiver to the LHR. Your PIM join will be sent upstream from the LHR towards the FHR. Once that is done, they'll build a multicast tree downstream from the FHR down towards the LHR towards the receiver. So this, you will see the outgoing list or the oil list state this. Right? For example, only this link is supposed to forward to this subnet. So this will prevent loops. VSX support, PIM-SSM supported on both the FHR and the LHR. You can do VSX towards the source, where you can do VSX lags towards them, or if receivers, there's VSX here. VRF support, because this is non-VXLAN. If you want to do VRFs for multi-tenancy, it's supported. But take note, if there are many switches in the middle, right, every link would need to have those VRFs. So this link here would have both the green VRF1 and the purple VRF2 enabled. So you could use sub interfaces or just a .1Q trunk to carry those VRFs. That can be done. Right? And you could have duplicate IPs because VRFs would do support that multi-tenancy. PIM-SSM ACL support. So by default, IPv4 SSM range is 232/8, and the IPv6 SSM range is FF3X/32. Okay. That means these sources here should be using IP addresses from those ranges when they send out. Okay. You could use ACL to block or allow traffic. Here on the FHR, I have an ACL that I say only to allow this group. All other groups should be dropped. You can do that. Or if you want to modify the default SSM range, that's also possible. So maybe this application wants to use the 233/8 range instead of the 232 range. You can modify the ACL to allow that. Or even like for V6, FF4X instead of FF3X. Just modify this to allow the new range. PIM-SSM and MSDP interaction. So MSDP uses rendezvous points. So basically, what I'm trying to say here is all the groups used by SSM, MSDP should not advertise out. So this is the correct interaction, and it is true in 10.9CX. For groups within the range, no MSDP source active messages will be accepted, generated, or forwarded. Even if you change it, or if you modify the ACL or use the default, both the interaction is correct. It will not be sent out. Caveats. It's not mandatory to only utilize PIM-SSM. Right? In the network, you can have parallel deployments of both PIM sparse mode with your bootstrap router and your rendezvous point for the non-SSM range, but also use SSM for that 232/8 range. We have your 239 for the normal PIM sparse mode. So both can be run in parallel. It's not either or. On VSX switches, take note, you need to use PIM active-active when your clients are connected downstream via VSX lag for faster convergence. This is not specific to PIM-SSM. Even PIM-SM, if you do enable that, have VSX, you need to enable PIM active-active. ACL for that. This is an example of what it looks like. You can see just normal ACL, but only the multicast group parameter here is supported. If you put any other values here, it will not be used, right? So change the group here, use the group here. If you modify the range like this here, you want to have the 239 as an SSM IP range, and you still want to accept the default range, you need to permit it, right? Otherwise, the default range is denied and you can't use the default range anymore. So just be aware. The ACL. And of course, I mentioned again, IGMPv3 and MLDV2 are required between the receivers and LHRs to request for that specific multicast source. But if your receivers are not IGMPv3 or MLDV2 capable, you would need this feature called PIM-SSM mapping. It's not supported today, but it is planned for future release. Again, many receivers do support these in their stack. Maybe some old device, right, they do not support that. Configuration-wise, this is what it looks like for IPv4. I have this for the FHR. We have the ACL. As an example here, I just want to allow this 232.10.10.10 group. Okay. And interface-wise, downstream, you have the normal IP addresses, your OSPF, your PIM sparse mode. Okay. There's no specific SSM PIM command here. It's just normal sparse enable. On the sources, you will do the same thing, right? PIM sparse mode enable. IGMP really is more for the receivers, but to be consistent, you can also enable here in case there's a receiver on this subnet. This is for unicast, OSPF, and router PIM. You want to enable it globally and enable PIM-SSM here. So if you do want to attach an ACL, you just add another line, PIM-SSM with the ACL that you map to. That's the FHR. If it's a transit device here, or LHR, this is what it will look like. So on your uplinks, you have your IP addresses, OSPF, and PIM as well. If there's a receiver subnet, SVI, you have your IP address, you have your active gateway, could be, right? If it's VSX, you have your OSPF, you have IGMP for V4 towards the receivers, and you need to enable PIMSSM. Because there's no ACL here, transit or LHR, just enable router PIM, enable, and specify PIM-SSM. For V6, it's very similar. On FHR, same thing. If you want to have an ACL to only allow this, put it in your access IPv6 ACL, FF32, for example. On your downstream, you have your IPv6 addresses, your OSPF v3, your IPv6 PIM6 sparse enabled. Okay. On the source, you have IPv6 addresses, OSPF, PIM sparse enabled, MLD, if that's the source. Router PIM6, you enable it, you enable PIM-SSM, and you attach your ACL. So it's very similar to IPv4, right? Same thing for the transit or LHR example. This is upstream, uplink, IPv6 address, OSPF enabled, PIM6 enabled on your upstream. On the receiver subnet, do the same thing, IPv6 address, OSPF, and MLD, because it's IPv6, you need to enable MLD to listen to those source messages. PIMS, you need to enable PIM6 as well. Router, OSPF, enable that. Router PIM6, enable that, and PIM-SSM. Okay, best practices. So you need to remember, under router PIM, remember to enable PIM-SSM, otherwise it will not be active. Enable PIM sparse mode between your PIM routers and on the SVIs facing your sources and receivers. Ensure that the default SSM range is used by the multicast source. Okay. If it's non-default, you need to modify the ACL and you need to add the default range if those are desired. Troubleshooting wise, have a topology diagram with your interface and IP details ready. You always want to check your physical cabling, make sure your neighbors are seen. You can check that using show LDP neighbor, and you want to make sure that your unicast network works before you even troubleshoot PIM-SSM. So make sure unicast works. Source and receivers, they can ping and they can trace route through the network correctly. Between the loopbacks, fix those issues found before even starting PIM-SSM. Okay. So again, number one is basically checking unicast routing, make sure that works, fix that if there's any problems. Number two, check your configs, make sure they're correct on the FHR, LHR, and transit devices. Once you do that, you need to check your PIM neighbors are seen. Make sure the routers see each other. And number four, you see those joins from the receivers towards the LHRs. If the receivers are trying to join it, you should see those joins on the command. Finally, if it works, your en route should be seen downstream, starting from the LHR, right, all the way up. So every device should have a incoming and outgoing interface. Okay, check unicast routing. I mentioned, right, this is the receiver. You need to make sure you can ping your source for V4 and V6. Make sure that works and fix it if there are problems for unicast. This applies to both V4 and V6 PIM-SSM. Make sure the configs are correct. So you can refer to those sample configs that I mentioned earlier. Check your PIM neighbors. So show IP PIM neighbor, that is the command you would use. Make sure on your expected interfaces with other PIM routers, you do see a neighbor. Okay. On your uplinks and maybe your transit interface. This is the SVI. And these are the uplinks, 49 and 40 and 50. So both for V4 and V6 is the V4 command. The V6 equivalent is here. Show IPv6. Yeah, see? Instead of PIM, you have PIM-SSM. On the LHR, if those receivers are sending joins, right, it could be IGMPv3 or MLDV2 joins, you should see those joins come in on your LHR. So this example, you can see that this receiver is trying to join this group here. Okay, this receiver is trying to join this group, this SSM group. And you can see the source here. That's the server, multicast source, remote source that he wants to join. Applies to both V4 and V6 SSM. And this is the V6 equivalent command. Instead of IGMP, use MLD V6. You might need to do a packet capture to check if the receiver sends those joins correctly. In case this command doesn't appear correctly, it's not what you expect, you may need to do a Wireshark. So this is the config to mirror those traffic towards a packet capture or Wireshark device. So you should see the unicast. Yeah, the unicast. You can see this is a IGMP join. So he wants to join this multicast group with this source. So this is the S, G. The S is here at the bottom, the G is here, the group. This is the unicast address of the receiver. Finally, you want to check your MRoutes. So on the FHR, you should see connected to the source, you should see the S, G. The S is the unicast source server address, and the group is here. Under SSM MRoute, you should see true if this is really SSM. Incoming interface, outgoing, this is downstream towards other PIM routers. On the transit router, you should see the same thing, S, G, MRoute, but the difference will be incoming and outgoing. Incoming will be a routed port normally, outgoing will also be a routed port forwarding. Finally, on the LHR, you see the S, G, true, incoming, the uplink, outgoing will be the SVI towards the receivers. This is the IPv6 equivalent command. Instead of IPMRoute, it's IPv6 MRoute. On the VSX switches, take note, only the DR will state outgoing interface. You see I have 1A and 1B switches in VSX. So 1A doesn't forward. You can see incoming interface, SVI, because it learns that stream from the SVI, from the peer, but there's no outgoing, because you do not want to prevent to have duplicate traffic, right? So 1B is the VSX switch that forwards out. Incoming is the uplink, outgoing is the SVI towards the receivers. Okay. So how do you check which VSX switch is the DR for an SVI? This is a command, show IP PIM interface, your SVI interface. Okay, you can see they have IP addresses, and the designated router will be stated here. Okay. So 220 this is the IP of this 1A, but the designated router is 221. Right, let's move on to the demo. So this is what I have here. I have a source, this unicast address. I have a receiver of this unicast address, and yeah, I have FHR, this non-VSX. I have LHR, that's VSX. I have transit devices that are non-VSX. I'm going to show you before and after. There's no SSM, no multicast running through. I'm going to show you like MRoute, what do you see? I'm going to show you IGMP, what do you see? And once the stream is flowing, I'll do a failover, shut down the link to show you that the impact, right? PIM failover impact. So let's proceed. Okay, so this is my source. You can see here, 30.11.21. 30.11.21. That's the receiver. Let me ping to my source here. 20.11.21. make sure unicast works. Okay. If this doesn't work, again, don't even bother trying to troubleshoot multicast. Okay, so now we established that unicast works. Let's check a few things. Switch 4 is the FHR. It's connected to the source. MRoute. Okay, this is what we see. We see the S, G, the source, and the group. SSM is true. Incoming is the SVI, but there's no outgoing. Why? Because there's no stream being requested so far. So this is correct. You shouldn't flood. It shouldn't be forwarded if there's no interested receiver. Okay, for the multicast stream. So that is correct. Let's move on to the other devices. For example, like the transit devices. So there's no MRoute because again, there's no multicast traffic flowing through. You shouldn't see it, but you should see like PIM neighbors. Okay, you see there, the neighbors, they're active on the uplink on the transit interfaces, for example. On the LHR, same thing. VSX device 1B at the bottom. Okay. So you should see PIM neighbors. It should be active. You can see how long they've been up. And you shouldn't see any MRoute if there's no active multicast stream. IGMP. You do not see any interested receivers for a particular SSM group. So this is non-SSM. Okay, now that we've done that, let's start the multicast. We have a packet capture, so just to show you. It's about the IGMP join. So right now, this is going to happen. Start the stream. Request to join that. Open network stream. Right. I'm trying to join this S, G is the source, unicast address, and the group. 232.10.10.10. You can see now it starts to work. This is the SSM stream working. Okay, so let's stop this packet capture. What do we see? UDP, this is the actual multicast stream. You can see lots of it. And let's take a look at the IGMP. Just filter IGMP. Okay, you can see here. This is receiver IP, right? IGMP v3. If you drill in, you should see his S, G request below. So he says, I want to join this source with this group. So that's why he could actually see the stream working. Next, let's have a look. Here, this is the switch 4 is here, FHR. Now, see previously there's no outgoing interface. Now that the multicast stream is active, you will see the difference. Outgoing is now 1150. So this 1150 is the downstream. Okay. If you go to the transit devices, for example, this guy, switch 2, so you can see 50 is the one. So switch 2, we shouldn't see any active multicast stream. Okay, we can verify that again. Here, nothing's seen. If you go to switch 3, you would see it. Okay. Or we can just skip it and just go to the VSX switch below, just to verify. Here, 1B, IPM route, you can see. Now, incoming interface is 50. Outgoing is the SVI towards the receiver. Incoming is 50. 50 is here. So that's from switch 3. So switch 3 is receiving it and forwarding out. And switch 1B sees it and forwards out to receiver, SVI. Okay, so that's the M route. Let's look at the IGMP groups. What do we see? Okay. So for this group, this SSM group, you do see a stream active with the source. And yeah, this is the reporter. This is the receiver that actually requested for it. Okay, so that's working. Next, I'm going to show you the failure. If we shut down this link on the 50 link traffic, the stream should reroute to 49. Okay, show you the impact next. So with that, let's run the unicast and multicast. Show you the impact. Okay. Unicast and multicast is running in the background. Here. Switch for. This is the FHR here. So 50, that's what we want to shut down. Do show IP MRL again, just to make sure. Currently it's 50. Okay, we're going to shut down port 50. Let's monitor the unicast and multicast here. Okay, unicast, no impact. Multicast, the video is still flowing as well. So you can see there's minimal impact. If you refresh the MRL, you can see now 49 is being used to forward the traffic. So you can see if you do have a failure, your multicast traffic shouldn't be impacted. Okay, so that's it for the demo. Let's see what else I have. That's it.